Hello, my name is Hans Griebel, and I'm the lead programmer and researcher at Climatology, Inc. And today I'm going to describe to you the API we have written to allow other programmers to replace the CCCSN website that we view as inefficient and difficult to use. Basically, our API is based on MySQL and a Django is a Python web framework. The idea here being that the CCCSN website is sitting on a huge mass of very valuable data, a couple terabytes in fact, but their interface to that data isn't the greatest, and what we've decided to do today, or over the course of a couple months, is provide a clean interface between this data and programmers such that they could write their own higher level implementation to access that data and display it on the web or whatever they might want. So basically our goal from the start has always been to take this data and output it in XML format in a clean, well-defined way that programmers could easily understand and then go right on top of this API. So today I'm going to show you a number of different functions that we've written, and the first one I want to show you is called variables. So here you can see that I've called variables. The server Django framework is running locally on my host, and I've called the variables function. It doesn't take any arguments, and it's just displayed all the variables that are currently available that we can use in the database. And this is just a starting point where if you wanted to say find the sea level pressure in Canada over 1960 to 1990, this would be where you would want to go to see a list of all the available variables, so to speak, that you could use. And then you could use that variable number and a number of our more advanced functions so that you could do whatever calculations you desired. This function, variable/2, this is the argument for this function is the number 2, and that corresponded with the variable that you saw before, sea level pressure. Now this is just a helper function that describes what the variable is if you know the number beforehand. Now I want to show you another function called max variable, and this function will actually take for a given assessment, model, and experiment. This function will turn the maximum value of that variable possible over all given time periods. So in this case we are using the Canadian regional model, and we're using the Canadian regional assessment, and we're using the 20th century simulation experiment, and we're looking at air temperature. And I'm not sure where this longitude and latitude is, but it's just what I put in, and the actual air temperature, the max value that we see here, is 18.9097. That's just an example of, if you knew the assessment, model, and experiment number, and longitude and latitude, you could easily find the maximum value of that variable over all time periods. The next function I want to show you is called time drift. Now, this is a little bit different, but it's related to max variable in that given a specific assessment, model, variable, an experiment, and a time bound, and this time bound would be a given year and a given end year. So you could say between 1960 and 1990, and between the months of January and August, I want to return how the variables change in between those time segments, in between that time bound. So I haven't showed you any XML output yet, and I'd like to do that. So here I've just run a query using the AR4 assessment and the Canadian Centre for Climate Modeling. That was people that did the modeling, and it was done with the same 20th century simulation as the previous example, and the variable here is the total precipitation. So this would return the total precipitation in 1960 for the given longitude of 60 and latitude of -80 degrees. And this is between the first and third month, and also for the year 1961 between the first and third month for that variable. So we've come to the close of our screencast, and I'd just like to point out that in conclusion, our API is easy to use and learn. We use standard naming conventions and patterns. We output in XML, and XML is parsable by a great deal of software. It's easily represented and it's understandable. And error messages are always well defined. I mean, it's definitely possible to put in the wrong assessment that doesn't exist, and we will tell you through our function if that so happens. And constantly new functions are always being added, so it's very easy to extend the library. And I'd just like to thank you for watching.